All right, hello. Today's lesson is on 4.1.1 degrees and radians. Degrees and radians are just two different ways of measuring the size of an angle. Most of you guys are going to be pretty familiar with degrees, the fact that there's 360 degrees in a circle. With radians, there are 2 pi radians in a circle. All right, first off is degrees. There's not a lot to talk here. You already know degrees. There's 360 in a circle, but there is one new thing that you may not be familiar with. It doesn't show up often, but it's kind of interesting. It's how we can subdivide angles. So there is something called decimal measure versus DMS measure. Now, DMS measure stands for degree, minute, second, and it's how we can subdivide an angle. Like if you have a half of an angle or a half of a degree or a fourth of a degree or a tenth of a degree or something like that. Normally, we just deal with it the way we deal with any other numbers. We subdivide it into decimal points, right? Like 97.53 degrees is 97 whole degrees plus 5/10ths of a degree plus 3/100ths of a degree. It's just a way of having it saying it's not quite 97 degrees, it's not quite 98 degrees, it's part way in between. How much in between? It's 0.53 degrees in between, right? You guys know how to deal with decimals. We have dealt with decimals for years at this point. You know how that works. But there is another way that angles can be subdivided. Instead of subdividing it using decimals, we can subdivide it using minutes and seconds. So this would be an angle that's subdivided in degrees, minutes, and seconds. That would be a 97-degree angle, 31 minutes, and 48 seconds. So degrees, minutes, seconds is just another way of subdividing an angle. So we have parts of an angle, right? It's a little bit more than 97 degrees, but not quite 98 degrees. It's the same thing like this. In fact, these are the same size angle. It's just different ways of showing it. All right, last thing I should talk about before we actually start translating between decimal measure and DMS measure is the symbols. That symbol means degrees. We've already known that before, right? So like there's 97.53 degrees. This symbol with one little apostrophe, that means minutes. That means seconds. So this is 97 degrees, 31 minutes, 48 seconds. All right, let's start trying to translate between the two. Decimal measure. Here we have 47.5 degrees, 47.5 degrees. Without doing a whole lot of work, you could probably figure out what the DMS measure is on your own. What would that angle be in degrees and minutes? See if you can think about that, pause the video, and see if you can come up with an answer. All right, if you said 47 degrees and 30 minutes, you would be exactly right. That 30 minutes came from the fact that you had half of a degree. That's like half of an hour, right? Half of an hour is 30 minutes. Since there are 60 minutes in a degree, just like 60 minutes in an hour, 0.5 of that would be 30. So that's 30 minutes. So the way that excuse me. So the way that 30 showed up was it was literally the 0.5 times the 60 minutes. All right, let's see if we can do the same type of thing with this, because this one we probably can't figure out quite as well in our head, but we can use the same concept. I've got 120 whole degrees there, so 120 degrees. Plus I got a little bit left over. How much left over do I have? I've got 0.15 degrees left over. Well, 0.15 degrees, if I want to translate that into minutes, since there's 60 seconds in a minute, I'm going to multiply that by 60. 0.15 times 60 is 9. So it's going to be 120 degrees and 9 minutes. It divided evenly. There wasn't anything else left. So that's done. There aren't any seconds. It's just 120 degrees, 9 minutes. And again, the way that 9 came from was the 0.15 times my 60. All right. This last one's going to be just a little bit trickier. Let's see if you can start it. All right. How many whole degrees do I have? I've got 14 whole degrees. So I've got 14 degrees. Plus, I got some left over, right? I've got that 0.22 of a degree left over. So to translate that into minutes, I'm going to times it by 60. So 0.22 multiplied by 60 is 13.2. But I'm not going to put 13.2 here. I'm just going to put 13. There's 13 whole minutes plus 0.2 minutes left over. So that'll be into seconds, right? So I got to say, well, if I've got 0.2 minutes left over and I got to change that into seconds, you take that times 60 because there's 60 minutes in a second. So it'd be 60 times 0.2, which is 12. There it is. All right, now please note that when I said I had 0.2 left over, it didn't have anything to do with this 2. That was just a happenstance. It had to do with when I did 0.22 times 60, I got 13.2, which was 13 whole minutes. That's where that came from. But this 0.2 was how much of a minute I had left over. It happened to have been the same as that 2, but it might have been a 0.8 or a 0.9 or a 0.7, right? Whatever it was, that's what I'd have to times multiply by 60 again to get the minutes, to get the seconds left over. All right, let's try doing it the other way around. All right, so the other way around, I've got 5 degrees and 14 minutes. So that's literally 5 whole degrees plus 14 minutes. Well, 14 minutes would be 14/60ths of a degree. So plus 14/60ths. Plug that in your calculator, you're back into decimals. 5 plus 14/60ths is 5.23 repeating. All right, same type of thing here. 28 minutes. So I got 28 whole minutes. Sorry, 28 degrees. I've got 28 whole degrees plus 14 minutes. So plus 14/60ths of a degree, because there's 60 minutes in an hour, or 60 minutes in a degree, plus, careful here, 33 seconds. I'm not going to add 33 over 60 because that would be like adding 33 more minutes. That's not minutes, that's seconds. In a degree, there are 3,600 seconds in a degree, just like there are 3,600 seconds in an hour. So I'm going to add 33 3600ths. 28 plus 14/60ths of a degree plus 33 3600ths of a degree is 28.2425 degrees. All right, last up, radians. Degrees are not the only way to measure angles. We can measure them in radians. So we should talk about radians a bit. Radians were defined in such a way that if you had an opening that was exactly 1.2 radians, then this arc length would be exactly 1.2 feet. They're devised so that the angle of the measurement is the exact same as the arc length, provided your radius was 1. It's kind of nice. Since a full circle is 2 pi radians, we tend to measure radians in pi. So we'll say, hey, instead of calling an angle 1.2 radians, we might call it pi over 6 radians or something like that, whatever number that happens to be. So we tend to measure radians in terms of pi, but they don't have to be. Pi over 6 radians would be 0.5236 radians. It'd be the same thing. I could call this 0.5236 radians. Means the same thing. It's the same measurement. Well, approximately, because I rounded that. But tends to be, we'll actually write a radian measure in terms of pi. So since we've got a different unit, degrees versus radians, we should probably actually talk about how to convert between the two. It's actually pretty easy. All I need is a conversion. I know there are 360 degrees in a circle, and that's the same as 2 pi radians. If I look at just half of a circle, my life is even easier. In half of a circle, how many degrees are there? 180 degrees. How many radians is that? Well, it's half of a circle. A full circle is 2 pi radians, so half of a circle would be pi radians. Since 180 degrees is the same as pi radians, I can use that as a conversion to go between degrees and radians. And we do it like this. If I have 150 degrees, I want that to be no longer degrees. I want it to become radians. So I'm going to just have to multiply by some kind of conversion, some kind of equal number that doesn't change the value. I want degrees to go away, so I'm going to put degrees on the bottom. I want it to turn into radians, so put radians on the top. And then I'm going to say, hey, I know there are pi radians in 180 degrees. You notice if I do this multiplication now, that label degrees is going to cancel out with that label degrees, and I'm going to be left with a label of radians. So to convert from degrees to radians, you just multiply by pi over 180. In this particular case, I would have 150 pi over 180 radians, which we could probably simplify pretty nicely. That's the divide by 10, that'll be 15 pi over 18 radians. We could even go further, divide both those by 3, 5 pi over 6 radians. So 150 degrees, that's the same as 5 pi over 6 radians. You guys might want to pause the video and try the same thing for 100 degrees. I'm going to do it right now. If I had negative 100 degrees, again, I need to multiply by a conversion. So I'm going to put radians on top, degrees on bottom. There are pi radians in 180 degrees. When I multiply those degrees and those degrees are going to cancel out. I'll be left with just a unit in radians. So it's negative 100 pi over 180 radians. Do a little bit more simplifying, divide top and bottom by 10. That's negative 10 pi over 18, which we can go even further. Divide both of those by 2, negative 5 pi over 9. All right, let's try it the other way around. Converting radians to degrees, same type of thing. I've got pi over 6 radians. I want to change that to degrees, so I got to multiply it by a conversion factor, but this time I've got this label of radians that I want to get rid of, so I put that in the denominator so that they end up cancel out. And I want it to turn into degrees, so I put degrees in the numerator. There are 180 degrees in pi radians, so I multiply by that. That label of radians cancels out, and I'll be left with just a label in degrees. Oh, even better, take a look at this. Not only do the radians labels cancel out, but that pi and that pi are going to cancel out. Sweet, which makes it even nicer. In this case, I just get 180 over 6. And 180, that divides nicely by 6. 180 divided by 6, that's just 30. All right, this one, 5.9 radians, it doesn't have that pi up there, so it's not going to be quite so nice and divide out. I've got 5.9 radians. Again, just multiply by that conversion factor, 180 degrees over pi radians, because that label, radians, is going to cancel out with that one. And then I've got an annoying one, 5.9 times 180 divided by pi. I'm just going to use my calculator for that. That is 338.045, approximately. I'm rounding here. The decimal goes on forever because, of course, pi is irrational, and the decimal goes on forever. All right. That's the type of stuff you're going to be doing today. Your assignment is 4.1.1, 1 through 23 odd, 39 and 41. Please note, problems 39 and 41 are in page 326, but the instructions are on the page before, 325. So when you get to those problems, be sure to go back a page and read the instructions so you're not just staring at it and wondering what the heck you're supposed to do. See you guys later.